Okay, so since we believe in this makeup of the universe is made up of 5% ordinary matter, the universe is made up of 25% dark matter and 70% dark energy. That conclusion will have an influence on what we think is going to happen to the fate of the universe. How will the universe end? How long ago did it begin? Those questions are answered by the makeup of the universe. Okay? So the fate of the universe and the age of the universe are kind of related questions. Okay, so we have a deceleration parameter, Q, holds the key to answering both questions, how old the universe is and how it will end. Of course, we like to boil things down as simple as possible to a formula, to make things easy. So we have this deceleration parameter, Q. Q equals half omega 1 minus 3/2 omega lambda. Okay? So this holds the key to how the universe will end. So if we think there's no dark energy at all, then the Q is equal to half of omega. Then we have to determine what's the mass density of the universe. So far we know that the universe is flat, right? All the measurements. So if it's flat, this is equal to 1. So Q is equal to half. If universe is flat, and there is no dark energy. If we think that the universe is positively curved, no dark energy, if it's positively curved, that means lambda O is greater than 1. Okay? Positive curvature. Lambda O is greater than 1. It's going to make the universe positively curved. That means Q is going to be greater than half. You see? So that means universe is, this will make the universe closed universe. Closed universe. If the lambda 0 is less than 1, that's negative curvature. Negative curvature. Q will be less than half. So I'm assuming there's no dark energy. Let's say there's no dark energy. You have 3 options that could have. Half, greater than half, less than half. Half will give you a marginally bounded universe, greater than half, closed universe, less than half, open universe. Okay? So before our discovery of dark energy, these were the 3 models of the universe we used to believe in. So omega 0 is the ratio of the density of the universe to the critical density for flatness. The universe appears to be flat, therefore omega 0 is 1. So out of these 3 options, these were back in the 1980s, 1990s. We believe either the universe is flat and therefore marginally bounded, closed, or open. Then once we determined that it was flat, then that told us that this was the best option. Q is half. See, about prior to 1998, Q is half of 1, half. Why? Because we determined that it was flat, and you have 1, so you put 1. This is the best option. Okay? But since we discovered dark energy, lambda L is 0.7, what happened? That changes the equation. You get half of 1 minus 3/2 of 0.7. You get Q is negative 0.55. So as long as Q is negative, it means the universe is accelerating. So if Q is less than 0, accelerating. You see, half, universe is marginally bound, greater than half, closed, open, accelerating. So as long as there is dark energy causes the universe to accelerate faster and faster, faster. Okay? So since it's negative, it doesn't really matter what the number is. As long as it's negative, the universe is accelerating. So before, in the 1990s, there was always a debate. Is the universe going to expand, 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 stop, and then recollapse? Is the universe going to expand forever? We didn't know. Some people said it's going to recollapse one day. Now, after that, no one even argues that it's going to recollapse. The conclusion is it's going to just expand forever. Faster, 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 faster. Okay, so different possible fates. So what I wrote over there is here. Okay? If Q is greater than half, the universe is said to be bounded or closed. You see here? Q is greater than half, closed. It will continue expanding until it reaches a maximum size. Then it will recollapse into a big crunch. Some people were arguing for that before in the 1990s. After this, it can continue to expand and recollapse forever, in which case it would be called the oscillating universe. So oscillating universe was proposed in cases where it would expand, stop, recollapse. Expand, stop, recollapse. Then it would go oscillate. Okay? If Q is a half, the conclusion is the universe is said to be marginally bounded. It will continue to expand forever, but it will be on the verge of recollapsing. So it's going to continue to expand, but slow down, slow down, slow down, slow down, slow down, but always expanding. Before 1998, this was a very good option. Okay? Either this or this. If Q is greater than 0, less than half, the universe is said to be unbounded or open. See, that's this one here. Open universe, Q is less than half. It's said to be unbounded or open. It will continue to expand forever, but its rate of expansion will slow down. But as long as Q is less than 0, that means it's not decelerating at all. It's actually accelerating, you see? So the universe is said to be accelerating and open. It will continue to expand forever at an ever-increasing rate. Since Q is negative 0.55 from that previous page, we appear to be living in an accelerating universe caused by the dominance of dark energy. Okay? It will continue to expand forever at a faster and faster, faster rate until big freeze. Right? Why the big freeze? Because as space expands, it cools down. So one day, the average temperature of the universe will be almost like absolute zero. This is very, very cold. The last things to remain will be the black holes, but they will evaporate also. Okay?